just use our calculator here. So what we got is 2 degrees, 43 minutes, 5 seconds. Enter into the calculator, press the change button. 2.718 to 2 decimal places, 2.72. Okay, that's no big deal. Next one is 3.14 in degrees, minutes, and seconds. So press the change, press the button here. 3 degrees, 8 minutes, and 24 seconds. Okay. Now, in the diagram, right shows a right angle triangle. Angle A marked A. Given that cos A equals sin A, show that this triangle must be isosceles. Okay. I'm going to make up 3 lengths, x, y, and z. Okay. I'm going to write down is that cos A is adjacent over, so SOHCAHTOA. See how hard chase a horse quadratic. Cos is adjacent over hypotenuse, so that would be x over z in this case. Sin A, which would be opposite over hypotenuse, is y over z. So if cos A equals sin A, this implies that x over z equals y over z. And then cancel the common denominator. This implies x equals y. Therefore, it's isosceles. Okay. Cool. C. For the right angle triangle has a length 7, 24, and 25. Find the smallest angle in the triangle. Give your answer correct to 2 decimal places. All right, so let's go for this one to be the 24, this one to be the 7, and this one to be the 25. So they're 25, you're 24, and you're 7. And we'll call this angle A. You can use any function you want here, guys. You could use, we're going to be using sine inverse, cos inverse, or tan inverse, whichever one you want. Sine is opposite over hypotenuse, so it would be 7 over 25. You can use sine inverse 7 over 25. You could do cos inverse 24 over 25. Or you could do tan inverse 7 over 24. All of them will give you the same answer. I'll just go for the tan inverse, just because it was the last one I did. It's going to be a small angle. 16.26, and to 1 decimal place, that'd be 16.3. Okay, that's all you gotta do. Now we're on to question 9. A shape is made by placing a small cube on top of a larger one, as shown. The cubes have edges of length 1 unit and 2 units. Find the total surface of this shape. Now, I'm trying to think of what we're doing here. What I'm going to do, guys, is I'm going to get the surface area of the entire, I'm going to get the surface area of the 2 cubes separately first. Okay, so if you imagine each side on this one is it's a 1 by 1, so each side is area equals length multiplied by width. It's a cube, so it's going to be 1 by 1, which is 1, whatever, an area of 1. And then there's 6 sides, so it's going to be multiplied by 6. So the area of the small cube is 6 units squared. Okay. Now, probably write that out. The area of the larger cube, however, it's 2 by 2, which is 4. And 4 multiplied by 6 is 24 units squared. Okay. Now when you add the 2 down together, you get 30, but there's a problem. The first problem is that this surface here is not exposed. So you're taking away the surface, you're taking away one of the sides on the small cube, and you're taking away the same area on the large cube. So it's actually going to be 24 plus 6, which is 30, but then they're both missing part of their area that's covered because one's sitting on top of the other one. So it's going to be take away 2, which is going to be 28 units squared. Okay. Or 28 square units. It's probably a better way of saying it. Okay, next one. A line segment AB is a diagonal from the base of the shape as shown. Find AB, give your answer in short form. No bother. Well, we know that it's a 2 by 2 triangle, 2 by 2 square on the bottom. So that means that this diagonal in question is 2 bottom, 2 on top. It's a right angle triangle because it's basically a box or cube. Okay, so we need to find the length of AB, which we will now call x. So x squared equals 2 squared plus 2 squared. X squared equals 8. And then square root of 8 is x. You can leave it as that. Or some people might write down 2 root 2. Okay, next one. The right angle triangle ABC is constructed inside the shape A as shown. Find B to C. Give your answer in short form. Okay, this is going to be a tricky one, so I might just diagram a bit smaller, a bit more manageable. Okay, I'm just going to draw this in 2D. So there's A to C and there's A to B. So that's C, that's A, this is B. Now we already know A to B is 2 root 2, because that's what we calculated last time. We know the height of the cube from here to here is 2. Now this height is 1, so that'll make that 3. So now we can do Pythagoras' theorem. We'll call this length y to find out what B to C is. So y squared equals 3 squared plus 2 root 2 squared. Put all that into the calculator and get y squared equals 17. Then y therefore equals the square root of 17. Okay, last one. Find the length of the part of the line BC that is inside the larger cube. So the length of BC that is inside the larger cube. What we're going to do here is we're actually going to do similar triangles to my knowledge. I'll pause it for a second. Okay, so we're going to use similar triangles using the last, see the last diagram. I'm just going to do it like this, right? So here's what we're going to do. So here's what we know about the last triangle, which is this one here. The cutoff point is 1 at the top, and the whole length is 3. So what I have to find out is, I know the full length of this is root 17. So I have to find out what part of BC, which is the diagonal. So my goal is to find out the length of this yellow section here. So please remember, we're not seeing 2 triangles, we're actually seeing 3 triangles. We're going to go with the large triangle like so, and we're going to go with the small triangle. They are similar triangles. Okay, so they have corresponding sides. So if this is root 17, and for argument's sake call this x, which is my target, this is 3 and this is 1. So we're going to do big over small. So corresponding side 3 divided by 1 has to be in the same ratio as root 17 over x. Cross multiply. X is divide on the right, which is multiply on the left. So we're going to get 3x equals root 17, and finally x equals root 17 over 3. Oh, sorry. Oh, sorry, inside the larger cube. All right, I'm just going to get the part in the smaller cube and then take it away. Sorry, guys, I'm not actually after the yellow line. I'm actually after the green line because it's in the larger cube, but I can sort that out anyway. I know how to do it. It's no big deal. Okay, so here's what we're going to do. We're then going to do the yellow line is root 17 over 3. So therefore, to find out what the green line is, we just get root 17, which is the entire length, take away the yellow length, which is root 17 over 3, put that into the calculator. Root 17 over 3. And we get 2 root 17 over 3. So that's no bother, once again in short form. Okay, my bad. But we got it right in the end. It's always worth checking your answers, guys, okay? Now, question 10. In this question, all lengths are in centimeters and areas are in centimeters squared. The diagram shows a rectangle with sides length 7 and y. The value of the area is equal to the length of its perimeter. So area equals perimeter. That's an interesting one. Okay, let's get the perimeter first. Perimeter equals, remember perimeter is when all the lengths added together on the outside, as if you're running a lap around the outside of your shape. That is the perimeter, okay? So it's going to be 7 plus y plus 7 plus y, which is going to be 14 plus 2y. Now the area is length by width, so the area is simply 7 multiplied by y, because area equals length by width. Now we're told that the two of these are equal to each other, so 14 plus 2y equals 7y. So bring it over to your side, we get 5y equals 14, and 14 divided by 5, which I believe is 2.8 centimeters. Okay, so that actually was the answer. Now we're on to 10b. The diagram shows a rectangle whose lengths are x and y, where x is bigger than 2. Find the value of the area of the rectangle. Find the value of the area of the rectangle is equal to the length of its perimeter. Use this information to write y in terms of x. Okay, so perimeter equals x plus y plus x plus y. Perimeter equals 2x plus 2y. Area equals length by width, which is xy. So now we got perimeter equals area, which is 2x plus 2y equals xy. Next thing we're going to do is put them equal, try and isolate the y's out. So it's going to be 2y. Actually, we'll bring the 2y over to the xy. I just want to keep everything positive. So 2x equals xy minus 2y. I'm going to spin this around so that xy minus 2y equals 2x. I'm going to factorize out the y. Y into x minus 2 equals 2x. And then finally I'm going to bring down the x minus 2, which is multiplication on the left, which will make it division on the right. And we're done. Okay. If I multiply top and bottom by minus 1, you could also have this answer. Would also be acceptable, or this answer would be acceptable. Whatever you want. Okay, they're all the same. Now, question 11. Fiona finds the volumes of 5 different cylinders. Each of them has a height of k centimeters. Complete the following table below to show the area of each of the 5 cylinders. Okay. So, it's going to be another interesting question. Okay. Area of a cylinder is, volume of a cylinder is pi r squared h. So it's pi times 1 squared times k, which is the height, which would be pi k. The next one's pi times 2 squared times k, which is 4 pi k. The next one's done for you. It would have been pi times 3 squared k, which is 9 pi k. I think we just have to square the numbers out, guys. Just square the 4 and you get 16 pi k. Square the 5 and you get 25 pi k. Alright, there we go. Pretty easy start off to the question. Now, 11b. Is the sequence of the volumes in the table linear, quadratic, or exponential, or none of these? Give your answer. Okay, so it's 1 pi k, 4 pi k, 9 pi k, and 16 pi k. Okay, you can probably stop at that stage. Okay, so the first difference is 3 pi k. Second difference is 5 pi k. Third difference, is 7 pi k. So that's the first differences. Then the second differences are 2 pi k. and 2 pi k. So this means it's a quadratic, and the reason being is second difference is the same. Or the differences of the difference. Okay. Now, question 12, which I'm hoping is the last question. A packet of sweets comes in the shape of a closed triangular base prism. It has a height of 8 centimeters and a triangular base of 4 by 4 by 6. Construct an accurate net with the prism. Show all your construction lines clearly. Alrighty, so apparently I'm going to need more lines or more blocks maybe. Alright, I have an idea. So the first thing to know is an easy one to do is the 6 by the 8. The 6 by the 8 are easy. Okay, so I might just start off with the 6 by the 8. I'm going to get myself some better graph paper than this. Give me a minute. Okay, so what I'm going to do is I'm going to start off with the base side. The base side is the 6 by 8 rectangle at the bottom. Okay, so I'm just going to extend this out a bit further. So it should be a bit more like this, okay? And then this one here should have stopped here. Then do it like that. Right, so that's a bit better, right? So I'm going to start off with this base one, which is 6 by 8, okay? So what I'm going to do here is 6 by 8. 8 long, 6 wide. 1, 2, 3, 4, 5, 6, 7, 8. 6 wide, 1, 2, 3, 4, 5, 6. And then extend it downwards like so. 1, 2, 3, 4, 5, 6. Now, great thing about no, that won't work actually. So next thing I have to do is I'm going to have to construct a triangle with 2 4 centimeters, or for 2 4 with lengths of 4 blocks. Okay, so I'm going to get my compass out like so. I'm going to measure 4 blocks. So I'm going to go here, and here is roughly 4 blocks. Then I'm going to go to the edge of one of them like so, and then I'm going to just mark off. You can see here it should be directly on the corner, very important. So I'm just going to mark off one length here, go back. You never know when constructions can appear up, lads, so you need to know your constructions pretty damn well. Here's my other one. There you go, just about met there, okay? Do the same thing on the other side. Make sure once again you're right in the corner. Actually, I'll just go this way. There you go. Once again, do a nice big arc this time. Don't risk them not intersecting with each other. Okay, just gonna flip this around. Gonna go to the other corner like so. Then we're going to make them intercept each other like so. And where they intercept each other, we know that's definitely a length of 4. So then you can draw a line from here into the corner like so. There's your 4 centimeter lengths. No, your lengths of 4. Okay. So that's part of your diagram done already. So next thing we got to do is we have to do this to 2 sides. So see this side here, I haven't done that at all. They're both 8 by 4s. So I'm going to do 2 8 by 4s here. So I go 4 blocks up, and then I go 8 across. There's my other one. And then if I go here, I go 4 down. Try and keep this in sync. 4 down, 8 across. And there we go. Done and dusted. There is our net. 4, 8, 8, 4, 4, 4, 4, 6, 6, 8, 4, 4, 4. You also do a ruler using centimeters, I just decided to use blocks. Different triangular prism has the base shown. Use trigonometry to find the length of the side marked X. Trigonometry to show the side. Well, it's an isosceles triangle. Because it's an isosceles triangle, I can drop a line straight down and cut that one in half. So I can cut this into a right angle triangle where this is 3.5. This is the hypotenuse of the triangle on the left. And I know the adjacent, so I can use cos. So I can use cos 70 degrees equals its adjacent, which is 3.5 divided by x. Multiply up the x, so we get x cos 70 equals 3.5. Cos 70 is multiply on the left, which makes a division on the right. So x equals 3.5 divided by cos 70. And 3.5 divided by cos 70 is 3.5 over cos 70 is 10.23. All right. So 10.23 to 2 decimal places. Now, next part. We're missing part 2, are we? All right, there we go. Now, the prism shown on the diagram on the right has a height of 12, no bother. 3 faces are labeled A, B, and C. Find the area of each of the faces labeled A, B, and C. Give your answer correct to the nearest centimeter squared. All right, so is that the one we just did a second ago? Okay, so let's find out what's going on here. So side A is a rectangle and it's 7 by 12. So A is 7 multiplied by 12, which is 84 centimeters squared. Side B, we're using the X in the last answer, lads. This prism means we're using the same prism, which means this is 10.23. So B is 12 multiplied by 10.23. And that would make it 123 centimeters squared. That's for the side B. Now for the triangle C on top, however, so we had to figure out what to do with this one here. Okay, I'm trying to figure this one out now. Doesn't give us the length of the same prism though. So we know X, we have 7, don't we? We have X and we have 7. So what's the other length? Oh, it's an isosceles triangle. So the other side is X as well. So the base, this is also 10.23 from here to here because it is an isosceles triangle. This is 10.23 as well. And that's 7. So what we're going to have to do is to get the area of C, we're going to have to, it's an isosceles triangle, so we're going to cut it in half for C. So C is an isosceles triangle, like so. And because we both know they're both 70 degrees, so we know that that's 10.23. We know that's 10.23. We know the bottom is 7, but if we cut 7 in half, we get 3.5, which is great. Then we can use Pythagoras' theorem to find out the height value. So it's going to be 10.23 squared equals 3.5 squared. What's a 3.5 squared plus height squared? And it's 10.23 squared, which is 104.6529. 3.5 squared, which is 12.25. Okay, bring the 12.25 over the other side and take it away. This is one of the harder ones we've done in recent weeks. 2.9. 12.25. 92.4929 equals 8 squared. Square root that. Root your answer. And we get 9.6126. Now, the area of this full triangle is a half base times height. And if the base is 7, we can get the height. Sorry, if base is 7, so we can do a half. 7 times 9.6126. Throw that into the calculator and you'll get 34 centimeters squared to the nearest centimeter. Okay, and I believe that is us done now. Alright guys, good effort. Hopefully this will help you get through your work.